Number one, this is from the very beginning of our unit. Find the constant of proportionality k and write an equation for the proportional relationship. And because this is our first test, I might as well give you guys another leg up. We're going to write what lesson each of these problems is from. So this one right here would be, I'm going to say 3.1 probably, right? Yeah, 3.1. All right. So if I see a table right away, my brain knows I'm doing arrows, okay? Arrows on the top, arrows on the bottom. From 2 to 3 on the top, that's a change of +1. From 3 to 4 is also +1. On the bottom, from 8 to 12 is +4. 12 to 16 is +4, all right? So on the top, I've got my x's. That's my change in x. On the bottom, that's my y. I've got my change in y. When I set up my fraction, k is equal to y over x, I'm going to swap the places, right? My bottom number goes to the top. My top number goes to the bottom, giving me 4 over 1. Zach, do you have a question about that?
Why do you put a triangle next to x?
Triangle represents change. So from this from this y value to this y value, my change in y is 4.
How does it represent? Is that just you or is that mathematical?
It's the Greek letter delta. It represents change. Yeah, it looks like a triangle, but in Greek it's the letter D. Okay? Don't worry about that. All you need to worry about is why aren't you over your x? You know that the y goes over the x, right? We've talked about that a lot. 4 over 1 simplifies to just 4, so my k is equal to 4. All right? Now, 3.3b tells us how we're going to do this second part, and that's writing an equation. Okay, the equation that we're going to write is in the form y is equal to kx, where all we have to do is take out the k, plug in the number that we found, which turns into y is equal to 4x. So 2 answers here, finding my k, and then using that k to write the equation. All right? Take a moment, finish copying that if you need to. Is that making a little bit of sense?
Yeah.
Okay. This is the easy stuff in the beginning. It shouldn't be too crazy. We'll get to the harder stuff on number 12, right? For number 2, fill out the table. I think that was 3.3 it might be. 3.2, 3.3-ish. Sure, let's say 3.3. All right. Oh, no, I'm sorry. I'm tripping. This is 3.10. I forgot what question it was. 3.10. All right, evaluating linear equations. So I've got this function, y is equal to 3x minus 2. I'm going to take each of these x values one by one and plug them in for x, right? So for my first one, y is equal to 3 times -1 minus 2. Forget that little thing. Y is equal to 3 times 0 minus 2. Y is equal to 3 times 1 minus 2. And y is equal to 3 times 2 minus 2. Again, I'm just taking all 4 of these x values and I'm plugging them in for x. One by one by one by one.
Pretty simple.
All right? And then we just solve. 3 times -1 is -3. -3 minus 2 gives me -5. So that's my y value for that first x value is -5. 3 times 0 is 0. 0 minus 2 is -2.
I got this right.
3 times 1 gives me 3. 3 minus 2 gives me 1.
Let's go.
There's my third y value. And 3 times 2 gives me 6. 6 minus 2 leaves me with 4. All right?
Debbie's in the charts.
Now again, that's just the first part. The next question is, does the point 3 comma 7 make the equation true? There's 2 ways we could go about doing this. I see you guys saying yes. You're absolutely right. 2 ways we could do this. We could plug them in for x and y. So 7 equals 3 times 3 minus 2. Right? I plugged in my y for y. I plugged in my x for x. 3 times 3 is 9. 9 minus 2 is 7. Well, 7 does equal 7, so I know that my answer is yes, it does make the equation true. Question?
The other way you can do it is just look at the change on the table.
Exactly, Zach. The next way you could do it is just by expanding your table.
That's literally.
If my x values are 0, 1, 2, well, my next one's going to be 3. Right? How do I get from 1 to 4?
You go
Plus 3.
and
So what would 4 plus 3 give me?
7.
7. Look at that. My next point on the table would be 3, 7. That is the point that we're given. So we're affirmed both ways that yes, 3, 7 does make the equation true. That one is kind of a long process because there's a lot of math. Is there any questions I could answer on number 2? Yeah.
What if I didn't extend the table?
Either way works. Whether you want to plug it in and solve, or if you want to extend the table and follow the pattern, both ways are perfectly fine. You don't have to do both. You can just pick one. Great question. Right? Whatever makes more sense to you works for me. Moving on to number 3. A lot to take a look at here on number 3. This would be 3.2. 3.2 in our notebook, graphs of proportional relationships. So we're talking about water use. My x-axis is my time in minutes. My y-axis is the gallons of water that I've used. The first thing I want to do when I have a problem like this is figure out what's going on with my axis. So in time, I see 0, a space, and a 2. So how many minutes is going to be in this little blank space here?
5.
From 0, in between 0 and 2 would be
Oh, 1, 1.
1.
I thought you were 1.
So for my time, I'm going by 1 minute. Every little notch is 1 minute. But every little notch on the y-axis, I've got 0, blank, 10, blank, 20. What would this first notch
5.
be? 5, right? So we're just following the pattern. 15, 25, 35, 45. Right? So if I want to fill out this table, I just got to look at the points. At 1 minute, here's 1 minute. I look over to the y-axis. There's been 5 gallons of water used. At 2 minutes, here's 2. I look up, I look over. There's 10 gallons of water used. 3 minutes yields me 15 gallons. I'm just reading this on the graph. 3, look up, look over, 15, 3, 15. And then we jump a bunch of spaces, go over to 7 minutes, which lines up with 35 gallons of water. And finally, 10 minutes, we look all the way up, we hit that point, we look all the way over, and I've got 50 gallons of water used. All right? Couple different ways to find K, right? K is just slope. So I could do rise over run, right? If I wanted to rise 35 gallons, right? I rose 35 gallons. I ran 7 minutes. What's 35 over 7? 5.
Okay.
Another way I could do it is with the table. I could do my arrows. From 5 to 10 is plus 5. From 1 to 2 is plus 1. Y over x is 5 over 1. Again, that's just 5. So I know that K is equal to 5.
And then the equation, can I say?
Yeah. Question?
Don't they have to all be the same? All the every time you add it has to be the same?
All the
It's not
changes.
same.
Good. I'm glad you brought that up. Let's take a look at this last part of the graph here, right? How do I get from 7 to 10?
Plus 3.
Plus 3. How do I get from 35 to 50?
Plus 15.
Plus 15. Right? If I put y over x here, I've got 15 over 3. What's 15 over 3?
5.
It's still
So it's
5,
still
right?
5.
This is what we see with a proportional relationship. I'm glad you brought that up because I didn't want to talk about that initially because I thought it would confuse you. But here, right, it's plus 20 over plus 4. 20 over 4 is still 5, right? Great question. So if my k is 5, I know my equation is going to be y is equal to kx. Zach, what's this equation going to look like?
Y equals 5x.
Just that easy, right? Take out the k, plug in the 5. Super, super easy. Our whole next unit, Unit 3B, is going to be about writing equations. This one is very, very simple, though. All right? Great questions on number 3. Any other questions on number 3 I can answer? Okay. 4 is just like our warm-up, right? We know it's proportional when there's no b value on the end. So of course my first equation is proportional. All right? Explain why it's proportional. What would my explanation be here, Anai? Because there is no b, or my initial value, if we want to be specific. We could just say b though, right? There's no b. That's not it. What was your reason, Zach?
I put yes, it's proportional because it has no initial value and it goes to the origin.
Perfect. Exactly right. So there is no initial value. I don't see a graph, so I can't visually look and see it's not going through the origin. But what would my b be here, Zach?
1 or 0.
0, right? And we know that 0 is at the origin.
Yeah.
So yes, of course, both of those reasons are right. You get full credit, both of you, for that. Okay. For b, is b proportional or non-proportional? Non-proportional. What would be my explanation as to why this is non-proportional, Jawad? There is an initial value. Great job. You said what, Zach?
And it doesn't go through.
And it doesn't go through the origin. Here's my initial value. It's the number hanging off on the end with no x behind it, right? If you do not include an explanation when it says to include an explanation, right, you're not going to get all the credit for that. Even if you are right. If you say non-proportional, great. You got to explain why as well. So make sure you're including these explanations. Now I do see a graph on this third one, Zach, right? What kind of relationship is here in C?
Non-proportional.
That's right. What would my reasoning be?
Because it doesn't go through the origin.
Exactly. Nice and easy. This one doesn't go through origin. Even though it's a straight line, right? We have to have both conditions met. Straight line through the origin. It's a straight line. Doesn't go through the origin. Goes through the b value of 20. So we know that that's going to be non-proportional, right? How are we feeling on 4? Good? It's pretty straightforward, right? Okay. Hopefully.
Easy. Oh, see, I didn't.
5 and 6, this is what we just did on Monday, and you guys said you were really, really confident with this, so I'm not going to spend too much time on this. Again, you see a table, your brain automatically draws what? Arrows. From point to point to point to point. Even if you don't know what you're doing, that should come to my head right away. Yeah. Sure. Give me one second. I got to sign back there. Okay, for number 5, how do I get from 1 to 2 in number 5? Plus 1. How do I get from 2 to 3? Plus 1. Okay, so far that's pretty constant. Plus 1, plus 1. On the bottom, how do I get from 5 to 10? Plus 5. How do I get from 10 to 20?
Plus 10.
Plus 10.
It's a variable.
All right, so this would be a variable rate of change. Right? What would my reason be as to why this is variable? If I was asked to explain, Eva, what could I say?
Because you're adding 5 to 1 each time.
Well, you're adding 5 the first time, but then you're adding 10, right? So is that a constant change? 5 and 10? No, right? So we could say it's variable because my change in y, in y is different. Right? Another word for not constant obviously would be like different. Just go, Alicia. For number 6, same thing. How do I get from 6 to 4?
2. Or
2?
minus 2.
Minus 2, right? How do I get from 4 to 2?
Minus 2.
Minus 2.
Or divide by 2.
How do I get from 17 to 11?
Minus 5.
Minus 6. How do I get from 11 to 5?
Minus 6.
Minus 6.
Prop. Or no value.
Well, it's not proportional, but it is constant. Right? What would my reasoning be as to why this is constant, Angelina?
Because it's minus.
Perfect. Change in x is the same. Right? Triangle x is the same. And my change in y is the same. All right? Make sure you're including your explanations on there. All right?
They see me.
All right. Any questions on 5 and 6? We still feeling good about those ones? Constant variable? Okay. Good. Flipping over to the back. Bruce, I'm sorry. Back to the front real quick. Sorry. Was that 3.12? Yeah. 5 and 6 are 3.12. Totally forgot. Number 4 was 3.9. All right, in case you want to refer back to your notes, I would probably recommend adding those in there.
Mr. Why do you have all these flags? Like, did you go all there?
No, it's just colleges. You guys got that 3.9, 3.12, Angelina? Yes, you're totally right. I'm sorry, I forgot all about that. I know it doesn't say it here, but we should be finding the m if it is constant. I think on the test it's going to ask you that. So what would my m be equal to here? How would I set up my fraction, Angelina? Say that one more time. -6, my change in y, over -2, my change in x. Right? What is -6 divided by -2 equal to? Alyssa? +3. That's right. Right? 2 goes into 6 3 times. Negative over a negative is a positive. Great. I appreciate you pointing that out. All right. Flipping over to the back. Number 7 is from 3.7, slope from 2 points. You guys okay back there?
Oh, yeah.
Okay. So in 3.7, when we were finding the slope from 2 points, right, the easiest thing for us to do is to make a what?
Table.
A table. Here's my little table. I've got my x's and my y's. All right. My first point here, 2, 3, is going to go in my first little slot. 2, 3. Right? My second point, 10, 7, is going to go in my second slot, just like that. So I'm just dropping the points down into my table.
Oh, I remember this one.
Now I see a table. What does my brain tell me to draw?
Arrow.
Arrows, every single time. For x's, how do I get from 2 to 10? +8. For my y's, how do I get from 3 to 7? +4. So is my m going to be 8 over 4?
No.
No, right?
4 over 8.
It's got to be y, change in y, over my change in x. So it's going to be 4 over 8. Now, is there a number I can divide both of those by?
2.
Even bigger than 2?
2. I mean 4.
4. That's all right. I know what you meant. We can divide by 4, right? So on the top, what's 4 divided by 4? 1. On the bottom, what's 8 divided by 4? 2. Can I simplify 1/2 anymore? Nope. There's my slope. Nice and easy. Right? Now, if I had a graph, I could have graphed these points too. Okay, I could have went over 2, 3 and made a dot, 10, 7 made a dot, and then done rise over run. Totally fine to do that too. On the test, you'll be given a table and a graph. You pick which one you're more comfortable with, okay? Any questions on number 7? Okay. Number 8, complete the table, identify the slope, and identify the y-intercept. What lesson was this? Was this 3.10, I want to say? Maybe I'm wrong.
I think 3.2.
3.8? No, not 3.7. 3.6, slope from a table. 3.6. All right, again, I see a table. What am I drawing? Arrows every time, right?
But first you gotta fill it in.
Well, to fill it in, we need to know what my change is, right? So we can follow the pattern. So on the top, how do I get from 0 to 1?
1.
Plus 1. From 1 to 2, plus 1. 2 to 3, plus 1. On the bottom, how do I get from 5 to 8? Plus 3. So what would my next y value be? 11. What would my next one be? 14. We're just following the pattern, right? We're assuming this is constant, so it's going to be a constant change, and that's what we get. So what would my m here be? What fraction can I set up? 3 over 1. 3 over 1. What does 3 over 1 equal to? Just 3. Anybody have trouble finding b on this problem?
Yeah.
Okay, good. I'm going to refer you back to a very specific spot in our notes. Okay, obviously you don't have your notes out, so you're not going to see this, but you do have this paper because we all have the same ones. When we were talking about slope-intercept form, right, and we were talking about our b value, our y-intercept, we know it's the point where the line crosses the y-axis. You guys pay attention, right? It's always the number being added or subtracted in an equation all by itself, but it's also the point with an x-coordinate of 0. Every single time. When you see an x-coordinate of 0, like 0, 3, 3 is my b. So on this table, take a look. Do you see any x-coordinates of 0 on this table?
No.
Look on my x's. Is there a 0 on my x's? Yes, there is. What number is right below that 0?
5.
5.
So b would be 5.
So my b is equal to 5. Okay?
I had no idea. I told you it was 5.
Okay.
I'm smart.
Good. Great job. Here's why. Let's take a look at a graph, right? 1, 2, 3, 4, 5. Right? If I was going to plot these points, take a look. If I was going to plot these points, right, 1, 8, there's 1, 8. Boom. If I was going to plot 0, 5, how many spaces would I go left to right?
0.
0. And then how many spaces would I go up? 5. 1, 2, 3, 4, 5. If I drew a line, right, we see that that's where the line crosses the y-axis. So whenever there's an x-coordinate of 0, the number that follows is always going to be your b. That's going to be something. You guys okay? Hooray, please. Okay. What was I saying?
You were talking about the 0 and a 5.
Okay. Matthew? Quickly. Yeah, hopefully that makes sense. Any questions I can answer about that? Number 8? All right. Dropping down to number 9. This is nice and easy. This was from 3.9.
In front of 9. In front of number 9.
Oh, yeah. Same thing with number 7 was 3.7. Interesting. So remember in 3.9 we talked about y is equal to mx plus b, where m, the number in front of my x, is my slope. B, the number all by itself, is my y-intercept. So if we're identifying the slope and the y-intercept for each of these, we're not doing any math at all. We're not counting. We're not drawing arrows. We're just using our eyes and making essentially a 50-50, we shouldn't be guessing, but it's a 50-50 guess which one of these numbers is m and which one of these numbers is b. What you should be looking for is the x, right? Doesn't matter the order. In A, what number is in front of x?
4.
3.
What number is directly in front of x?
3.
M, right?
Oh.
So what number would be my m?
3.
3. Yes, 4 is technically in front of x, but I'm talking about which one is right up next to it.
Okay.
Yeah. Because look, this in my equation, this little mx here, they're like a couple. They're a bonded pair, okay? I know. Yeah, the m and the x, right? They stick together no matter what. In this equation, that's my 3 and my x. Okay, let's come back together. So my m is 3. What does that make b equal to? Angelina? 4, right? It's the number hanging out all by itself. We could easily just switch this order around. Y is equal to 3x plus 4. If we want it to be in a more relatable format, right? But you should be looking at the x, like Zach said. Whatever number is in a relationship with that x, that's going to be your m. Right? mx, mama's x, right? They stick together. What about b? What's my m in number b?
3 over 4.
3 over 4? How do we know that that's my m and not my...
X.
That's right. It's connected to my x. Inseparable. Now this is where we got to be careful. What's my b? Negative
Yeah, 'cause
2.
it's a minus. Yo, my grandpa got that. Again.
All right? If we see a minus sign in there, that means that my b value is negative. Right? It's totally fine for me to have a line that crosses the y-axis at a negative point. Like that. Okay, can you guys stop, please? If you don't care, that's fine. But there's people around you that do care that are getting distracted by your antics. What's my m and c going to be? Well, I look in front of my x. That's right. It's an invisible 1, negative 1. That's in our notes right about here. Yeah, we've got an invisible 1 in front of your x. So that would be your m. But because we also have a minus sign, it's going to be negative 1. Now b is my number hanging off on the end. Do you see a number hanging off on the end? No, right? So my b would be equal to 0. All right. Any questions on number 9?
Nah. Pretty easy.
Okay. Number 10 is from 3.5, slope from a graph. Right? It's giving you a graph, asking you to find the slope. Pretty obvious that's the lesson we're going to be using, right? Slope from a graph. So I've got this line here. I see I've got a point right there. I've got a point right there. Now if I'm going to count my slope, it's going to be rise over run. Okay? M is equal to rise over run. Which point do I want to start at? This one on the left or this one on the right?
The one on the left.
We start on the left, just like we're reading a book. Am I going to rise first or am I going to run first?
You're gonna rise.
We're going to rise, right? You got to rise in the morning before you can go on a run, so we're going to rise first. The question here is now, am I rising up or down? I'm rising up. If I'm starting here at my house, I'm trying to make my way over to my friend's house, I got to go up the street before I can turn right. Yeah? Ray? Okay, yeah, we'll get to B in just a second. You're absolutely right. So how many units am I rising up here in this little block? 1, 2, it looks like 3. It's all right, the graph is a little tiny. We're going 3 spaces up. 1, 2, 3, 4, 5 spaces to the right.
3 over 5.
So my slope, rise over run, is going to be 3 over 5. Can I simplify 3 over 5 at all?
No.
Nope. Both prime numbers, nothing to cancel, nothing to divide. Now, Ray, you said my B value here was what?
3.
3. How did you know it was 3?
Because we began at 3.
Exactly. Great. I love it. You're connecting it to that other lesson, right? We begin at the B, right? So wherever I begin, well, that's at 3. That's going to be my B. Angelina. Say that one more time. Yeah, of course. Yeah, it's the point on the y-axis. Exactly right. Yeah, that's a good point to bring up because I'm not going to always begin. Like I could have began here if there was a point there, right? So it's not necessarily always where we begin. I appreciate you pointing that out. It's whatever point is on the y-axis. Okay, y-intercept, that's where we intercept the y. We should know that by now.
Technically, they're all X and all Y.
What?
You could just flip it on its side and then the X would be the Y.
Yeah, I see what you're saying. We're going to keep it on this side, though, okay?
And
I appreciate that. Well, I said, yeah, that was 3.5. Number 11, it's 3.11. I didn't do that on purpose. 3.11, right? If I'm looking at my equation, now we're given the equation, we got to graph it. So based on this equation, what's my m? -7 over 4. Good. I'm going to stick my negative sign in the numerator. All right? Now is 7 my rise or my run? My rise. If it's negative, am I rising up or down?
Yeah.
I'm rising down. So I'm going to do a little down arrow. This is fairly fresh in our brains, right? We remember this lesson?
yeah.
4 is my run. What direction am I going to run?
Right.
To the right. Always run to the right. So I know where I'm going. I know how far I'm going. But I don't know where to begin. What's my B? On a 5. That's right. The number hanging off on the end, like we've been saying all day, that's my B. So now this is what Ray was saying, right? I'm going to begin. I always forget the B. I'm going to begin at 5. Am I going to begin right here at 5?
No, because B is on the Y.
That's right. I'm going to go to my y-axis. There's a little y up there in case you forget. Okay? Eva, Sheena, please stop talking. I'm going to go to my y-axis. I'm going to find positive 5. Boom. Make my beginning dot right there. Okay? From that beginning dot, what direction am I going to go?
Down.
I'm going to go down. How many spaces down?
-7.
7 spaces down. So from here, 1, 2, 3, 4, 5, 6, 7 down. How many spaces am I going to run? 4. In what direction? To the right. 1, 2, 3, 4, 5. I'm going to make my second dot right there. Oh, I'm sorry. I was looking at the wrong number. Thank you. 4 spaces. So ignore this little point right here. All right? Is that the only point we have room to make on this graph? No, right? I could keep going. I'm going to go down 1, 2, 3, 4, 5, 6, 7 more. 1, 2, 3, 4 more to the right. And make another dot. Do I have space to reverse back in the other direction? No, I don't have space. And that's fine, right? So you'll be given a ruler on the test tomorrow. Okay, if you don't use your ruler, there's points taken off. Okay, we all know how to use a ruler. So you line up the points, make a nice straight line. Okay, and that's what we get. Now, just to check, I'm not quite sure I did this right. From left to right, is this line going uphill or downhill? It's going downhill, right? If I drew a little person up on the left, told them to walk to the other side, they'd be walking down this very steep hill, right? If my line is going downhill, Jawad and Eli, if my line is going downhill, I should have a negative slope. What's that? What was I seeing then? Some kind of nonverbal interaction? Not right now. It's okay. We should be looking this way though, right? You too. You should be looking this way too. Okay. Perfect. We're almost done. It's the last one. And then you can go if we have time. Number 12. The equation y is equal to 5x plus 15. This is where a lot of us had issues because this was our newest lesson, right? But it's our, should be the freshest in our brains, 3.12, right? So this equation represents the total amount of money spent at Jamba Juice after buying a reusable tumbler cup, right? So one of those hard plastic cups like Starbucks has that you get a cheaper smoothie if you get it refilled, right? You guys know what I'm talking about or no?
No.
Yeah.
Oh, wait,
So
no.
something like this, right? It says like Jamba Juice on it.
yeah,
You
yeah.
buy it, and then when you bring it back in, you get a discount.
Yeah.
Yeah,
That's 20% off.
yeah. Something like that. So here X is the number of smoothie refills purchased over time. Okay? Right away. Right away, I'm given this very valuable piece of information. Because the first part of my question is to make a table, identify X and Y in the context of this problem. So what are we talking about in this problem? Just in general, what is this problem about? Is it about
Cups.
About cups? What kind of cups?
Tumbler cups.
Tumbler cups at where? Jamba Juice, right? It says right there. So I'm given my answer in my question. X is the number of smoothie refills. What is X? Oh, X is the number of smoothie refills. Duh, it says it right there. How can I figure out what Y represents? Is there anywhere in this problem that tells me what Y represents? Yeah? Alyssa, where do you see it? On the bottom? Oh, on the bottom of the graph right here? Well, that's my X. Where's the Y, though? Yeah, it's up on the side, right? Y is my total cost in dollars. Okay, Y is my total cost in dollars. Right? So that should be easy. That's just knowing where to find information on the problem. Yes? Okay? Now, forget the context for a second. Let's graph this line. I'm just going to look at y equals 5x plus 15. What's my m for that equation? What will my slope of this line be? 5, right? Do I want to leave it as 5 or do I want to do something with that 5? We want to turn it into a fraction, right? What can I put under the 5? A 1? Right? Positive means I'm rising up. Denominator means I'm running to the right. And then what would my b be equal to? From the equation, what's my b? 15. So if I go to graph this, I'm going to begin at making a point at 15. Well, where on my y-axis is there a 15? I don't see a 15. In between the 10 and the 20, right? Each little notch is $5. There's 25, 35, 45, 55. So I'm going to make a beginning point at 15, right there. Now I'm going to rise 5 and run 1. This is where we have to be careful, right? I saw a lot of people going 1, 2, 3, 4, 5 over 1.
That's not what.
Right, Ray and Sylvie? Why do I not want to do that?
Because you don't want to do that because
Right. So why don't I want to do that, Anahi?
Because it's counting by 5.
Because it's counting by 5s, right? So if I'm rising up 5, really, I'm only rising up one little square. From 15 to 20, that's a rise of 5. You see what I mean? So we got to pay super close attention to the axis. Then I'm going to run 1, make a dot. Rise, run, make a dot. Follow that pattern all the way up. Using my ruler, I'm going to make a line. All right. Now I can fill out the table. So I've bought the reusable tumbler. How much was the reusable cup? Think about it for a second. How much was the cup itself?
15.
$15, Zach. Exactly right. So if I haven't gotten any refills, I've still paid $15 for the cup. Okay? 0, 15, that's this blue point that I made right there. Okay? Now, I already spent $15 on the cup. I get 1 smoothie refill. How much have I spent in total now? 20. What about 2 refills? 25. 3 refills. 30. We could keep going forever and ever. Right? Well, we don't know how much a smoothie costs. Jamba Juice is like $8-9 for a smoothie or something now, right? It's like super expensive. So what we're changing here is plus 5. right? So let's say it's an $8 smoothie. If you bring in your own cup, you get it for $5, and you're saving $3 every time, right? So within 5 visits, 3, 6, 9, 12, 15, you've paid the cup off just by the money that you've saved, right? That's kind of what we're talking about here. So the slope, my slope was 5. What does the 5 represent again?
Spend money to get money.
What does 5 represent? Well, let's go back to what Zach said. What does the 15 represent?
The total cost.
The total cost?
Of the tumbler.
The cost of the tumbler. Cost of the reusable tumbler. So then what does the 5 represent? The cost of what? A refill, right? Cost of each smoothie refill. You pay $15 for the cup. You pay $5 every time you get a refill. That's how we would interpret that equation, this whole relationship here. All right. So 3.12, that was the last lesson we did. Not all of us were here for that. I highly recommend going home tonight and getting these notes filled out, okay? Especially this one right here, talking about the savings account. Is that what this is? Yeah. Talking about the savings account, right? You start with a certain amount. We talked about that, Anai. We only have 4 minutes, unfortunately. In advocacy, you can. Any final questions about this before we get out of here? Quick show of thumbs. How confident